All right, here we go. We're going to correct the assignment, page 206, numbers 3 through 14, compound inequalities. Remember, there's two different ways that we can set up this first problem. So we can either write it as two separate problems. So negative 3 is less than x plus 2, and x plus 2 is less than 7. Then we use all of our scales and inverses that we've been using, and we're going to subtract 2 from both sides. So negative 5 is less than x, and we're going to do the same thing on the other side. So subtract 2, and x is less than 5. Now remember, for graphing, we always put our 0 on our number line, and at negative 5, is it an open or closed circle? We're going to have an open because we do not have the equal to. And remember, when you read inequalities, you always start at the letter. So x is greater than negative 5, and greater, the numbers go to the right. So now, from the other side, when we read it, we're going to put at 5, we're going to put an open circle, and it reads x is less than 5. Less than 5 shades to the left. So now, because it's an and problem, we are going to shade between negative 5 and 5. Going on to number 4, this is also an and problem. If you look at the x, it is sandwiched between the two inequality signs. So we can write this as two separate problems. And remember, we always write up to the inequality sign and then stop. And then we write the other half of it. All right, what do we have to do to get x by itself? That says a plus 1, so the inverse of a plus 1 is going to be that we're going to subtract 1. So 4 is less than or equal to 4x. Now that says 4 times x, so the inverse is going to be to divide both sides by 4. Now if we just go ahead and graph this one right away, remember to put 0 on your number line, and at 1, is it going to be an open or closed circle? And because this says less than or equal to, we are going to put in a solid. Now remember, when we start reading this, graph it from the letter. X is greater than, so we shade to the right. All right, let's go to the next one. We're going to subtract 1 from both sides. So 4x is less than or equal to 12. The inverse operation of 4 times x is to divide both sides by 4. So we have x is less than or equal to 3. So at 3, we're going to have a closed circle, and we're going to shade to the left. Because these are overlapping in ands, the solution has to work for both numbers. So the only part that works for both numbers are in between.
Max Sims, Uncle Zach is waiting.
Continuing on with number 5, I'm going to show you the second way that you can solve this. So if we put lines through our inequality symbols, we now have 3 spaces. We still focus on the x in between, but instead of rewriting it as 2 problems, we're going to focus on this 2, and because it says plus 2, the inverse operation is to subtract 2 from everything. Now notice this is a different method than what we've been showing. So 2 minus 2 is 0, is less than x, is less than 2. Now we can go ahead and graph this. And so we have 0 and 3, and both of them are going to be open circles because we do not have the equal sign. And x is bigger than 0, and it is less than 3. So we are going to shade in between from 0 to 3. Number 6, we're going to do that same method. So what numbers are by x? We have the number 2, and we have the number 3. Remember, we need to do PEMDAS backwards, so we take care of our adding and subtracting first. So this says a plus 3, And the inverse operation is going to be subtract 3 from all three sides. So we have 8 is less than 2x is less than 18. Okay, now what we're left in the middle is 2 times x. The inverse operation of times is to be divide by 2, divide by 2, divide by 2. So 8 divided by 2 is 4. Inequality, x less than 9. On our number line, remember to put a 0. At 4 and at 9, both of them are open circles. We do not have the equal sign. And remember, you always start reading from the x. So x is greater than 4, and x is less than 9. This is an and problem, so we shade between. Number 7, we already have 2 separate problems here, so we can just go ahead and solve. So this says x plus 2, and the inverse operation of plus 2 is subtract 2, subtract 2. Please make sure that you are using your calculators so that we get a negative 8. Now, do we need to flip our sign because we subtract? No, we only flip our sign when we divide or multiply by a negative. So at negative 8, we're going to have an open circle, and let's read that from the letter. So it says x is less than. Numbers to the left are less than. Continuing on to solve the other side, we're going to subtract 2 from both sides. So x is greater than 4. So at 4, we have an open circle, and reading it from the variable, x is greater than, so we're going to shade to the right. Number 8, this is an OR problem. So we have 2 separate problems already written, and we're going to graph them both on the same number line. So this is r minus 1. The inverse operation is to add 1 to both sides. So r is less than 1. So we put 0 on your number line. At 1, we're going to have an open circle, and it says r is less than, the numbers go to the left. In our second problem, we are going to, inverse operation of subtracting 1 would be adding 1, so r is greater than 5. So at 5, we're going to have an open circle, and we read it from our variable. So r is greater than 5, and numbers greater go to the right. Notice an OR problem, and the arrows go away from each other. Number 9. The inverse operation of adding 2 is going to be to subtract 2, so n is less than 1. Put your 0 on your number line. So we've got a 1. We're going to have an open circle at 1, and reading it from your variable, we're going to go less than. Subtract 3 from both sides, so n is greater than 4. So at 4, we have an open circle. Read it from your variable. N is greater than, so we graph to the right. Number 10, we have an OR problem. So right now, on your number line, you know that these are going to be shaded out. They're ORs. They're going to go out from each other. So to solve this, we're going to add 1, x is less than, and negative 1 plus 1 is 0. On the other side, that says minus 5. So the inverse operation of subtracting 5 is adding 5 to both sides. Please make sure you're paying attention to your signs. X is greater than, and negative 1 plus 5 is 4. So at 0 and at 4, we're going to go less than, and it's an open circle at 0. And at 4, it is also an open circle. They shade out because it's an OR problem. Number 11, our directions change here. They have it graphed and they have it shaded between -5 and 3 here. They want us to write the problem. So there's two different ways that you can write this. One way to write it is where x is between the two numbers. So we have a -5 and we have a -3. Write them just like you see them on the number line, and you put an x in between. And x is bigger than -5, and x is less than -3. Then you have to decide, am I including that value or not? Do I say equal to? And if they're colored in, we do say equal to, so we put the lines underneath. Another way to write this is just to write them one at a time. So a lot of us like to write the letter first and then the number. Now, if you look at 5, -5, which way? The numbers get bigger, 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 bigger. So we're going to put greater than, and because it's colored in, equal to. Looking at the second number, let's put the letter down first and the number -3. So if you look at -3, it is shaded to the left, which is less than. So x is less than or equal to -3. This is an and problem. Solutions need to fit for both numbers, both equations. Number 12, this is an or problem. They go away from each other or out. So I like to write my letters first, x compared to -3. Well, let's look at -3. The numbers get smaller, 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 smaller. So I need a less than, and because it's colored in, equal to. X is less than or equal to -3. On the second one, we have our variable x and your number 3. So where is it shaded? It is shaded to the right where your numbers get bigger. So x is greater than 3. We do not say equal to, so we do not put the line underneath. Number 13, this is shaded away. So we are going to do or. So we have two problems in here. So we've got x compared to 1. And if you look at x compared to 1, the numbers get smaller. So we're going to do less than. This is an or problem because it goes away from each other. And we've got x compared to 9. And if you look at 9, the numbers get bigger, bigger, bigger. So x is greater than, and because it's colored in, equal to 9. I can see I made a mistake on number 12, so I'm just going to flip back to number 12. And we have to add the word or in here.